My bench is extremely cluttered right at the moment, but all for a good reason. You see, in a recent video when I was going to test the printed circuit board light sensitive film that you apply the dry film onto the circuit board material, I designed a circuit board and it was going to be a simple circuit board, and then thought, no, what the heck, let's make it a fairly complex circuit board. And I ended up making this little LED tree, and it's all very stylish with its the logo all wrapped round underneath the bottom of it. And then I thought, what would be really interesting now is to test some of the printed circuit board manufacturing services, the prototyping ones that make small batches. And I decided initially to test Dirty PCBs, and then someone mentioned Seeed Studios. And so a few days later, I submitted the same files to Seeed Studios. Now, these companies have a sort of web interface, and Dirty PCBs are the strictest, but this is good actually, because up to now I didn't realise that the printed circuit board industry uses different extensions for the different layers of the printed circuit boards. I had traditionally just got my printed circuit board package to put them all out with the extension, I think it was GBR for the Gerber or Gerber. But in this case, Dirty PCBs is a list in their the page that they show how the things should be submitted, and they say they must be in the correct form. So all I did was change the extensions of the files to match. So what you do is you put all those files into a zipped folder on your desktop, and then you go to the website and you select choose file, and you choose the zip folder and load it in. Then, and this is where it was slightly more restrictive than others, the minimum number of layers they gave the option of was 2, and it's a single layer circuit board, so I had no choice. 2. If you choose the proto pack of 10, you get a choice of maximum 5 by 5 centimeter or 10 by 10 centimeter. Unfortunately, my circuit board came in at 5.8 centimeter, so it had to go up to the 10 by 10. And that had a small bearing in the price, but it had a big bearing in the postage. The postage is a lot higher as a result of that. You get to choose the type of material, FR4 prototype material. FR4 is a generic name for standard printed circuit board material. It's treated with flame retarding agents. You get to choose the colour of the solder resist, the thickness of the PCB. The default is 1.2 millimeters. I chose 1.6 because 1.6 millimeter is the standard PCB thickness. HASL, which stands for hot air solder leveling, it's the standard, it's the tinning of the pads. 1 ounce copper, which is the standard thickness, no stencil, and so I just chose the basic sort of setup. The difference between that and the Fusion service from Seed Studios, S-E-E-E-D, D Studios, Seed, it's got the same option, add your file. And you can download the individual files, or you can just load the zip. They interestingly give the option of FR4 aluminium core, the sort of like the stuff that's used for the LED lamps. I'm looking around and I'm not seeing an example of that. There should have been, but not to worry. But you know the stuff that the LED lamps use, which is the aluminium panel with the fiberglass and then the copper in the front. And they also offer flexible printed circuit boards. That's interesting. And they offer from 1 to 16 layers. I was able to then choose 1 layer, and that was a good result. Then you put the dimension in millimeters, which is also good. PCB quantity 10, different designs. That's when you're going to have multiple designs of the same PCB, because they'll charge you a bit more for that. PCB thickness, the default was 1.6. PCB colour, default was green. I chose that anyway. Surface finish, they offered hot air solder level, lead-free, ENIG. I think that's electroplated gold. I'm not sure. Hard gold, immersion tin, immersion silver. Enig, I'm not sure about that. You can choose the diameter of the solder, the mask dam. That's basically, the solder mask is the bit that stops the solder flowing between pads. And if you choose the standard, it makes it easier for them because it means they don't have to line the layers up so accurately. So they let you choose a standard of 0.4 millimeter, which is absolutely perfect, or 0.1 millimeter for where you've got an awful lot of tiny pads next to each other and you want that resistance to the flowing between them. They also offer copper weights of 1, 2 and 3 ounce. The only time I've ever used higher than 1 ounce was my power boards and my fairground light controls that I used 2 ounce, just for the extra current handling and robustness. Minimum hole size, again, 0.3mm is fine because, you know, ultimately, I think all the holes in these ones are 0.8mm. And the only reason they offer the selection here is because if you choose ultra thin, like 0.2mm drill sizes, it means they have much higher breakage. It makes it much harder for them to make the circuit board, so it'll be more expensive. And likewise, the track spacing, if you go too small with the track spacing, it makes it harder for them to manufacture, so there is extra surcharge. The most amusing site was Dirty PCBs, who are, well, let me read this bit. Why are you so flippant? This site was intended for friends and not the public. We'll process your boards, but because most services are offered at cost, we have very little appetite for demanding or difficult people. We really don't care if you want to take your business somewhere else, and it's not worth our time to deal with stupid questions or asshats. PayPal fee reversals, annoying emails and the like will get you banned from the site. It's like Mitch Altman says, don't work with people you don't like. Well, that's quite blunt. But anyway, it's a good enough approach because there are a lot of asshats out there. So the result, Dirty PCBs, I ended up getting the plated through holes on them, which, you know, it's not what I wanted. It would have been nice to have the single layer option. Because it's got the effectively pads on both sides, even though the ones on this side are not used, that actually makes it a wee bit trickier for desoldering if you ever, you know, if you screw up how you're making a circuit board like that, because plated through holes are always much, much harder to desolder components from. So I prefer the result from Seeed Studio, where it is the actual single-sided circuit board I want, with that nice clean front and just the pads and tracks in the back. I ordered the Dirty PCBs on the 1st of June and the Seeed PCBs on the 3rd of June. They both arrived together on the 21st of June, so it took about 3 weeks for both to be fulfilled, which is absolutely fine. The cost, the Dirty PCBs was £25.95, let's say, sorry, $25.95, let's say $26. The Seed was $15.39, so about $10 less. So, right. That means that, technically speaking, Seed were the better option. But I've got nothing against Dirty PCBs. They probably excel at different formats. It's just because I was being awkward and wanting a single-sided circuit board. I shall put links to both of them in the description down below. But now I have these circuit boards, and is there anything else I wanted to say about those, getting those made? No, not really. I think that it all went very well. It all went very smoothly, the ordering. So what I've got here, I thought, because the Patreon and PayPal supporters and the general supporters that view and advertising revenue all help keep the channel afloat, and because in recent times when eBay, I should say YouTube, went through that blip, and the advertisers were all going sort of, yeah, fussy and not wanting certain videos, you know, channels to be advertised on. And what happened was I saw the revenue from YouTube just plummeted at that point. It suddenly made me realize that when you're using YouTube as, you know, part of your lifestyle as such, all it takes is somebody just clicking a wee box at YouTube, and suddenly your entire income could stop. Everything, your channel could actually disappear overnight. There is no security in actual putting videos up on YouTube. And that made me really appreciate, at that time, the PayPal and Patreon supporters, because they are an independent channel, especially Patreon, in the sense that I can communicate with Patreon supporters a lot easier. The whole Patreon site is set up for communication, and it just makes things easier. If something happened, like my channel went down, I could immediately talk to the Patreon supporters. I could say, here's where the new channel is. It would just make it easier that way. However, to thank the PayPal and Patreon supporters, here's what we're going to do. I'm making, with single-sided board ones, I'm going to make effectively 10 of these kits. And they're going out to, well, one of the kits is going out to one of you. All you have to do to win the kit is just leave a comment down below. You can leave any comment whatsoever. And I'll choose one of you at random, and you get one of these complete kits posted out to you. And here's what you'll get. You'll get a box. It'll come through the post. It will have the lead. It will have it'll have 20 LEDs, it'll have 17 of these connectors pre-crimped. You'll have the circuit board, the resistors, solder, the little standoffs, and some fetching pink cable ties. The other kits, I'm going to build, let's see how many, I've got 8. You know, I should build one up. The one I build up now, I shall build on the double-sided board so I don't use one of these up, because I want to send out 10 kits. And that means the other 9 kits are going randomly to PayPal and Patreon supporters, and they'll know that they've won one of these kits, so to speak, when I contact them, because I can contact them all via email. And I've not done that yet. This will happen after I've put the kits together. So I decided to make it easier to assemble the kits, rather than supply the crimps and the cables and everything like that, because that's the hardest bit to do, is putting the wires into the crimps. I decided, let's prepare these all in advance, and then I thought about the numbers. Yeah, 10 kits with 16 plus 1 spare, so that's 170 of these, times 2. Yeah, that took quite a time. That, about 300 odds, yeah. 340 is that? I think it is. 340 crimped ends to get stripped, crimped, and so on. It took a modest length of time. And now what I'm going to do, I'm going to clear off the workbench, and I'm going to take one of these kits and show how to build it from scratch. Now, this effectively is just a repeat then of this video where I made this one, except the difference is that it will be with one of the actual circuit boards. So if you've seen that video and you don't want to see it all happening over again, then you could just skip the rest of this video and leave a comment down below to get one of these kits. lead-based solder, I don't know if I mentioned that, it will definitely be lead-based solder you get for the maximum soldering pleasure. So right now, I'm going to tidy off the bench and we shall build one of these kits from scratch, since this will be effectively the video manual for the building of one of these kits if you win and you get one. So I'll just clear the desk right now. Okay, the bench is clear, the soldering iron's up to temperature. Let's build this as it would be from the kit you receive. So for that reason, I've decided to go on the single-sided PCBs, and someone, and I'll talk to them about that beforehand, will get one of the double-sided ones. So let's start. And the first thing we're going to do is start by putting the resistors in. Now, when I'm wanting to get resistors out the strip in bulk, I just use a pair of scissors. Not Mummy's best sewing scissors, but a pair of rough scissors that I just use for mass decomponenting from bandoliers. It's just the fastest way to do it. In fact, I'll put those down in the bin right now. And I'm just going to roughly shape them like that. Worth noting that Seeed Studios, the printed circuit board company that made their circuit boards, put a reference number on the printed circuit board, as did Dirty PCBs. It's not uncommon, it's just a general reference for that circuit board. But Seeed Studios put it really neatly inside one of the resistor outlines at the correct angle. Very stylish. I think they're showing off. So let's get these resistors in. I suppose really the OCD in me should actually make them all point with the colour bands in the same direction. If at any point you notice a slight flickering on the bench, it's because one of the LED lights, one of the sections of 10 LEDs in it, is starting to go on this light up here. If I put this lens up, can I project that down? Am I going to get it? Am I going to get it? Where is it? There it is. Yeah, one of the sections has gone out, and it's gone out completely now, and the other one is on its way. Nice. Shitty LEDs. I knew it was a shitty LED when I put it in. I really should try some of the high colour rendering index LEDs. High CRI. What they mean by high CRI, colour rendering index, is that it makes, say for instance, greens and blues and reds and oranges look more accurate. It provides a better colour accuracy. Kind of mainly to do with sort of photography and modelling and stuff like that, and the film industry. So yeah, let's put some of these resistors in, and then I shall stick them in with sticky tape, which is always a good way to do it. Lets me put in bulk resistors quickly, or I could actually just place it down. If I recall, this was quite easy to just bang upside down onto the workbench to hold the components in, but you know what, this time I shall use a bit of tape. I shall use masking tape. Painter's masking tape to hold them in. Hopefully this isn't going to go horribly wrong. Put them all at funny angles. In that case, if I can put those ones in like that, then I shall put all the other ones in too. Yep, I shall do that. So I'll just fold these like this. You will be getting spare resistors. At some point I may get a batch of these circuit boards made and put it on the website, because it looks really nice. It's been lit continually, a prototype, since I made it. I took it over and showed my brother, and then he was all disappointed because I was taking it away again because he thought I was going to leave it. Maybe I should make him one. So let's get these resistors in. I do have a component lead forming tool, but I'm just going to do it by hand because, well, A, it's faster, and B, that's how you'll be doing it probably. Not everybody has a component lead forming tool. I got it a while back when I was manufacturing circuit boards to a sort of professional standard, and just felt that I should, you know, present that image of all the leads being properly formed and not just bent with fingers and rammed in. Not, I don't think it makes that much a difference really. So I'll be heading across shortly to Glasgow and then Edinburgh to work on various projects. I should really do a Glasgow meet at some point. I'm just not sure where to do it, because I don't know how many people would turn up, and where could you meet at the weekend that would not be busy, because Glasgow is a very busy city. It's full of hustle and bustle. Now, for accuracy here, I'll go completely by the book. I'll use the components that I supply, so that'll be this solder. Let's see how well a meter of this lasts. It should be fine. And I'm going to work my way around the outside, soldering all these leads. Nice, actually. It's flowing well onto the tinned pads. Very, very easy to make this circuit board. The hardest bit is probably going to be putting the wires in into the middle for the actual LED holders. The LEDs I've chosen are diffused, slow RGB ones, the ones that just cycle through the colours of the spectrum. I think it's red, green, blue, yellow, cyan, magenta, and then white, and then it cycles. It just keeps doing that pattern, but it does so slowly with a sort of transition. It's quite nice. It's amazing how they can put all that circuitry into just an LED these days, particularly the 3mm ones, although I've chosen 5mm ones because I think they're stronger. The way the circuit is arranged, the sockets each basically have their own resistor, and it will run on 5 volts. So you can use any LEDs you like, and you can swap them about willy-nilly as you need. And because it is only 5 volts, and it's current limited with the resistor, it means that if you put an LED in the wrong way around, all it's going to happen is it's not going to light. So I've got all the outer connections soldered. So I'm going to crop those now with a standard pair of cheapo snips off eBay, which should be treated as a consumable item. If you use these on heavier leads, the blades do gradually wear out. So can I pull that off? Yes, I can pull that off. Let's put the tape out of the way at the moment and make sure those are all lined up before I solder the middle ones. That looks pretty good. Let's solder the middle ones. Some LEDs, I've not tried it yet, but I think it would look quite nice. I've got some of the candle flicker LEDs. You can buy them on eBay. They're the ones with the flickering chip in them that just undulates up and down. And they do them in various colours, not just the sort of the standard sodium yellow that they used to. You can get them in blues, greens, warm whites. The warm whites are a bit harder to get, which is a shame, because that strikes me as being the correct colour for a flickering LED. Technically speaking, a golden white would be the correct one. Oh, this circuit board is a joy to solder. The pads are well spaced. It's the tinning just takes the lead solder extremely well. I wonder if the tinning is lead based. I have a sneaky feeling from the fact it offered the option of hot air solder level with lead free, the ROS compliant. I'm guessing that maybe the standard one, they are just flowing it with a touch of lead. There's that. It's looking quite stylish already. Let's crop these leads. And now comes the bit that could be frustrating. We shall find out when I start doing it. So I've supplied 16 are required, so I've supplied 17 just in case. And they're just wrapped together with a little spiral of wire that's not needed. It was just a good way to hold them together in the packaging. And if you look at the back of the circuit board, you'll see there's a plus symbol in the middle because everything, the positives all go into the middle. So the positives will literally go in like this. And I'm just going to solder one lead at a time. And this is where this could get very time consuming. Also, because all the middle pads are connected, they run into each other, you'll have to be careful not to flood so much solder on it bridges one of the adjacent holes, but that's unlikely to happen. I say that's unlikely to happen, it could well happen. And this is the tricky bit. Once you get one attached, you're going to have to try and hold the other lead in while not pushing it too hard, because if you do push it too hard, then as you melt the solder, on the lead, the insulation will potentially push back as you push the wire through. It's all a matter of just getting the feel of it. So I'm possibly, because this video could turn out a mammoth video otherwise, I'll just put a quick twist in that. Not too much, just so I don't put too much strain in that, but it keeps it neat. I may just solder a few of these and then just jump cut past the others because I'm not sure what I could talk about. I could talk about the impending work. The Royal Embromulated 2 is coming up. We've got an interesting lighting effect that may be used on it, which is a blast from the past. It's a xenon arc line by mode lighting, if they use it. I don't know if they're going to do that yet. They're looking at options, but they're trying to get an effect of pulses of light blasting along the arena. And you'd think, well, you could use LED, but it's very hard to get the same intensity from LED as you get from the traditional xenon flash lamps. An arc line is just, it's a classic. Basically, it's sections of plastic pipe that join end to end and just plug together. And you've got three connections going between them. DC, high voltage DC, about 330 volts DC, which is basically just full wave rectified mains. And you've got one data line reference to the negative rail, which sends a pulse. I'm going to try and solder two of these at once. Is that a good idea or not? And the effect is, because you can change the clock rate that the pulses run along at, and it's basically, it acts like a shift register. When you inject pulses in, the bright, intense pulse of light will rocket along the tube, and you can actually chase streams of them after each other. It's a very good effect. But it's not DMX compatible, which our lighting rig is, so I've made a little adapter box which will allow basic control. In hindsight, it would have been nice to, if the time had really allowed, to create some Arduino type routines that decoded the DMX and then converted it into streams of the pulses, the timing pulse and the sort of the strobe initiation pulse. But it would also have required custom circuitry to act as level shifters, but technically speaking it could have been quite easy. But the hardest bit would have been writing the Arduino software to basically create a clock from one of the DMX channel, and also the pulse initiation that sends the pulse streaming down the tube. Be quite interesting. I wonder if it's going to be reliable. It's such an old system now. And the strobe tubes, they do wear out, and the capacitors tend to leak after a while as well, because they're given quite heavy use. It's almost like a photography camera flash, but just being used as a sort of beacon strobe on a regular basis. So it does munch its way through the strobe life. Another thing we're going to do is, for safety, we're going to put an automated DMX control relay in that when the effect isn't in use, it will actually kill power to the whole thing, just as a precaution. Right, you know what? This could take a while, so I'm just going to jump to the end, okay? So I shall see you in a moment when I've put the rest of these in. This is an absolute delight put together. This is a really nice kit. I just love the way this has turned out. So the next thing we're going to do is we're going to put the cable on. And this is where, as always, I suggest testing the polarity of the cable. So this is a Poundland cable. And in it you'll get a random colour. Cut the plug off the end that goes into your phone normally, and strip it back by about an inch or 25mm, depending on where you are in the world, what your measuring system is. As I've said in the past, in the UK we use both. Our measuring tapes have inches and millimetres on them. So the one thing that's relatively sure is that the white and green, which won't be used by a power supply, and this is designed to plug into a USB power supply, they're not really going to be used, so we'll just crop them at slightly different heights so they don't short together. I don't think that really matters though. I shall strip these wires, and this is where, because these are quite thin, it's quite useful to use a stripping tool to do it. And then the really important bit, twist them and check the polarity, because it's pink and grey, which could equate to red and black for positive and negative, but you just never know. And the only way you're going to find that out is to bring in a meter, which is set to the correct voltage there, bring in a power supply, plug it into it, and making sure you don't short the ends of the leads together. Stick the red probe on the pink or red and the black and the grey, and because it's showing 5 volts without the minus symbol in front of it, that means the polarity is correct. If it was the wrong polarity, a minus symbol would appear in front of the 5 like this. So, yep, that's the correct polarity. That's nice. So now I'm going to tin these pads. Well, I'm going to tin the pads, and I'm also going to tin the leads by just flowing a little bit of solder onto the end, like this. Oh, noting that as I do that, the insulation is shrinking back quite quickly, but that's okay, there's plenty of clearance in this circuit board. So I'm going to flow some solder onto the positive. There's nothing too short onto under here if it does flow back too much. And then the positive is going next to the positive symbol in the middle, like this. So that's the pink one. Let that cool. Yep, okay. And the grey is going to the negative, which is clearly marked with the negative symbol as well. And I'm putting them on sideways just because ultimately it's the easiest way to do it. And reflow. Let it cool until it you can see the little change of state of the solder. Then I'm going to tie wrap this onto the back here, making sure those are nice and cool. Yep, they are. And I'm going to use a pink cable tie. The colour pink keeps cropping up in this channel because, for those who ask, because they aren't familiar with it, the reason I always get things in pink plastic is because there's nothing better than getting something electrically dangerous from China in pink plastic, because if something's going to kill you, you might as well do it in a complete lack of dignity by having something lurid pink thing throw you across the room. Oh, that sounds sexually suggestive again. Lurid pink things throwing you across the room. Or being thrown across the room by a lurid pink thing. Okay, the tie wrap can stick down underneath because we've also got these little feet that clip in. I've not tried these for size. They fit. These just push in, and they'll be little feet to stand up on. So you don't have the stuff underneath shorting out on your table. These can also accept screws. If you want, you can put small screws into them to fix something down tightly onto a surface. And we're almost there. We're almost ready to put the LEDs in, which could be any LEDs. But what I'm going to do now, I'm going to... How did I do this last time? To get the tree effect, I think I just grabbed it like this and twisted. That's working just fine. And latterly, I picked a few that were close to each other, say for instance these three, and twisted them together, and then splayed them out and maybe twisted another two a wee bit further. And by doing that all the way around, you can create a sort of very branchy effect, like sort of twigs and branches. And it adds to the realism of the sort of looking a bit like a tree. A bit like a completely fake electronic tree with LEDs in the end. Yeah, it's looking good. Very bonsai. Very bonsai indeed. I'm not sure the Japanese would agree with that. But for me, it's bonsai. Bonsai. And some, yeah, we'll twist these together as well and just have little clumps like that. Yeah, it's looking good. And then, let's put some LEDs in. So let's plug this in for a start. And grab the LEDs, which are in this little foil pack to protect them from static discharge, although I don't think the RGB LEDs are so critical for that because they have a reverse polarity protection diode in. I'm going to crop them down to about 10mm, which is just about 3/8 of an inch. I should have noted the polarity. There is a slight flat, which is supposed to be on the negative side. Let's find out if it is. Yes, it is. The first LED is lit. So let's crop all these LEDs down to about the 3/8 10mm mark. As I say, if you put the LED in back to front, let's just randomly ram one of these in. Wrong way round, just doesn't light. Put it in the right way round, it's lit. And there are spare LEDs just in case you get a duffer or have a little incident with one, or you just want to play with them. Keep in mind that if you get a standard battery like this and you put the long lead against the side marked with a plus and the short lead against the side that's recessed in the sort of lithium battery, it will power the LEDs so you can actually have it just changing colour on its own. You could do that with spare LEDs. Most people have the 2032 type lithium cells knocking about anyway. It's a very common size. This is almost complete. It's gone together very quickly. Well, it has for me, but then again, you know, see when you're enjoying a project, time kind of just flies by. Another colour combination might be all green, would be quite nice. Or those flickering LEDs I was talking about earlier. I've got some of those flickering LEDs here. This is a blue flickering LED. Let's just shove it in. Let's shove it in the wrong way round for a start, just to see if it's resilient. And then shove it in the right way round. Do you see that slight flicker under? So the whole tree could actually shimmer and flicker like that. That could be quite interesting. I've got some of them in blue and I've got some of them in green. But by far the softest, the most subtle effect is the soft colour change that I'm putting in at the moment. So I'm not even bothered to check the polarity now. I'm just going to shove them in. If they don't like, just turn them around. With the 5 volts, it doesn't really matter. With the mains voltage version of this, which isn't so safe, you could damage some of the LEDs, the traditional gallium nitride type LEDs, by putting them in the wrong way around. They don't like having their reverse voltage exceeded. Looking good so far. Looking very good. So remember, if you've not entered the competition yet, all you have to do is just leave a comment below. Just any comment at all. It could even be rude words. I'm not sure I really encourage that though. And I shall pick someone and email them or contact them in whatever way I can. That may mean that when you leave a comment, I may leave a comment in response to your comment asking you to email me with my email address. And then I shall delete that comment immediately so that it just doesn't spread the email, you know, so that I don't get peppered with emails. Right, that's it. I think that is looking really, really nice. That is looking very nice indeed. This is so good. So much easier than the sort of more complicated, big sort of LED bonsai type things. Yeah, that is good. That is very good. I shouldn't say this about my own thing, should I? It's like just patting myself in the back. I'm going to turn the light off here, and then I'm going to adjust the exposure, which is just going to be horrific. It's just going to flare up here, isn't it? And it's going to make everything look cold and harsh, even though there are lots of colours here because the LEDs are swamping the camera out. But yeah, that is the end result. So I'm about to upload this video, and then I'm going to start picking the Patreon and PayPal winners, who will be completely random. The first thing you'll know is when you get the email actually asking your address to post this to. And as I say, leave a comment down below and I shall pick another winner from you and send you one of these. So there we go. It's a good result. I like that a lot.